Hey, welcome to Module 1 and the Introductory Lab to Physical Geography and the Environment 101 lab course. So I have a hard copy of the lab, but if you look at the top of Module 1, you will see that indeed there is an electronic copy that you are going to use and fill in. In fact, I want you with all of the labs to fill them in before you take the lab quizzes, okay? Good. So if you flip to or scroll down to page 4, you will see that on page 4 it says Introduction Exercise 2, okay? That's what we are going to work through. But first, take a look at the board behind me. Behind me, we have the pH scale. pH stands for potential hydrogen. You don't have to know that, but that's what it stands for. And notice, it is a 1 to 14 scale. What it measures is the corrosiveness of a substance. This is one of the things that we're going to look at as we analyze water, okay? 7, which is in the middle of this 1 to 14 scale, is distilled water. That means all it is H2O molecules. It is completely non-corrosive. However, as you go from 7 towards 1, as you can see up there, what happens is substances become increasingly acidic. In other words, they're acids. And as you go from 7 to 14, notice that substances become increasingly basic. Their base is also known as alkaline. The further you go towards 1, the more corrosive a substance becomes. And the further you go towards 14, away from 7 that is, of course, the more corrosive a substance becomes. And if you look, you can see that on the lab, indeed, on page 3, there is a pH scale, and it gives you an idea of what some of these numbers represent, okay? So let's take a look at page 4, where it says Introduction Exercise 2. I'm going to read some of this, so that's just the way it's going to go. And then we're going to work through the experiment that you see on the following pages. So it says, quality water is colorless, tasteless, and odorless. Odd colors, tastes, and smells are from impurities in the water, which does not necessarily mean those things are dangerous. They just aren't water, H2O, like what 7 would be. To complete the following exercise, you must observe an experiment conducted by me, the instructor, on the linked video with water from 2 particular sources. One of the samples is store-bought bottled water. So in this case, it's this one, Aquafina, okay? So I got it down at the liquor store down the street. The other is from a source on the Santa Ana College campus, the ornamental fountain located near the administration building, and there's a picture of that fountain in the lab. So I just went out there and scooped out some water, and we're going to see what happens. Because, of course, if you have an ornamental fountain, isn't it something like a swimming pool in a way? You have to take care of it, otherwise everything turns green and you get a lot of insects in it and mosquitoes and all this kind of happening. Mold, I don't know, whatever else grows in there, moss. So I assume that they take care of it. And at the same time, with Aquafina, I would expect, myself personally, that something else is going on because you're going to drink this. You're probably not going to go out to the fountain at Santa Ana College and drink that water, okay? This experiment uses 2 500 milliliter beakers of water labeled A and B. So here's A. I'm not telling you which one is which. Here is B. Okay, so one of these is Aquafina, the other is the ornamental fountain. Beginning with beaker A, following the instructions described below in part 1 pH, your instructor will, that's me, test both of these samples, beaker A first, then beaker B, which you will then need to observe on the YouTube video attached to this module entitled Introduction Exercise 2 Water Experiment, okay? I know I don't read very well out loud, sorry about that. After completing the experiments described below in part 1 testing pH, your instructor will then move to part 2 and so on. There are 6 parts to this. While watching the video, you should be answering the questions included below in each of the 6 parts of this experiment. These questions will be part of your lab quiz for this introductory lab. By filling in and or compiling these answers based on the video presentation in advance, you can help yourself ensure that you do not run out of time when you're taking the quiz for this module or for any module for that matter. The last question is related to your expectations for bottled water. Is there a right or wrong answer for your expectations? Well, this is a science course, so the answer is yes, there is a correct answer based on a general expectation of what one gets when purchasing a bottle of drinking water and what one would expect to discover in an ornamental fountain. Science is not about feelings or emotions or desires or politics or hopes or beliefs. Science is simply about facts, evidence, and the ability to replicate something. That's it. Okay, so let's start with part 1, testing pH. Using one of the sample bags. So I have these bags here, and you can see, if you look carefully, that there's line A, B, and C on them. Okay, I'm going to take water from each one of these beakers, starting with A, pour it in, and then I'm going to add these little pills here, shake it around, and it's going to change colors. And based on the colors, we're going to use this chart, the tap water tour chart, to see what exactly we got, okay? So let's start with pH, all right? If we start with the pH, testing pH, what you do is you put one of these little tablets in there, you pour some water in there up to line C, you shake it around, and then you twist it, and then you hold it up to the color chart to see what's happening. So why don't we start with that? I have, here we go, number 1, this is page 6 up at the top. What is the pH of your samples? Are they acidic, basic, or neutral? Well, let's start with A, okay? So here is the pH scale right there. This is what A looks like. You tell me, what color does it look like? And based on the pH scale, what does that represent? Which of these colors does it look most like? Huh? All right, good. Record your answer. Do that. Very good. Now let's do the same thing for B. Here's the pH for B. Okay, this is B. So this is number 1B. What color does it look most like? Take a look carefully. Okay, record that, and then record whether that's each one of those is acidic, basic, or neutral. Look at the samples for A and B, and in figures 1 and 2 on page 3 of this lab, what substances do your samples correspond with? So you just look at figures 1 and 2 on page 3, and what does sample A correspond with? What does sample B correspond with based on the pH? Okay, now it says this: gently open the plastic bag for sample A. So this is sample A. I'm going to open it up. I'm not being very gentle, but let me see if I can get this done. And then what I'm going to do is I'm going to take a straw. Don't do this at home, dangerous. Here's the straw, reusable, and I'm going to blow in there, okay? As I blow in there, wow, look at that. What's happening to the color? Look at that. All right, so the color changed for sample A. So what you want to do now is first tell me that the color changed, and then what number did it become from what it was? Take a look there. What number did it become from what it was? Take a look carefully. All right, now we're going to do the same thing with B. So remember, here's B. I am going to take B, there's B, and I am going to open it up, and with a different straw, I'm going to blow into that one. So here we go. Open this up. Take a lot of time doing that. Different straw. Again, I'll put some color on here. Go on. Oop. All right, so there we go. Out of breath doing that. So let's take a look. And what happened? What happened to the color? And what color did it become? Which means what number did it become from what it was? All right, record that. Very, very good. All right, set this one aside also. All right, let's go to the next one. So it does say, why did the pH change in each sample? Why did the pH change? What's coming out of my mouth, my breath? What does that contain? I'll give you a hint. It's called carbon dioxide. Carbon dioxide is an acid. So what happened as a result of that? Now, part 2, testing chlorine. Fill the bag to line C with your water sample, add one of these pills, and then shake it up, and let's see what happens. So this is chlorine right here. This is sample A with the chlorine. Whoops, open that up all the way. Very good. Now it's open up all the way. Where's the chlorine? Wow. What do you see? I don't see much of anything. I think that's even below low. Yeah? And now, take a look here. This is sample B. That was sample A. Now we have sample B. Okay? I would just record that as none. Imagine if you don't do this and you're just sort of checking this whole thing. So going through it and not actually doing it, I don't know if you're going to get that right. Probably not. So make sure you record it. I saw no chlorine in either of those two. All right, now let's go to part 3. Fill the bag to line C, and let's go through and test copper. So now we're at part 3. We're testing copper. So let's look at, wow, this is colorful. Let's look at sample A. This is sample A. Look at that. What's happening with sample A? What do you see? What color does that look like? It's hard to do this backwards. All right, record that for A. Now let's take a look at B. It's pretty much the same thing. Incredible. There's B. So what does that look like? Looks like no copper to me. Yeah, I would say both of these are kind of no copper. All right, so make sure you record that for copper. Then it says copper stains porcelain, things like toilets, sinks, bathtubs, and so on. Are these samples likely to cause stains based on what you see? Well, there's no copper in them, so you have the answer, I think. Now let's do part 4, hardness. So we're going to take, once again, sample A. We're going to look at the chart. We're going to see what sample A gives us with regard to hardness. You can read what hardness is about. Is my phone going off? Is this hard water or soft water? Hard water or soft water? Okay, this is sample A, record that. This is sample B, hard water or soft water. Take a look again. Hard water or soft water. Those are significantly different. Sample A and sample B are very, very different from each other. And then the last one is iron. So let's take a look at iron. This is for sample A. Well, I mean, we're kind of back to what happened with copper, right? And with chlorine. I don't really see anything there at all. I would say iron on A looks like 0. What about on B? Iron, once again, looks like 0 again. I don't see anything in there. 0. Okay, well, record it as that. It's done. There isn't any iron at all. All right. And then you can see part 6 says this. Which sample do you believe is the bottled water? Which one do you think? Based on your expectations for bottled water, what causes you to think that? So make sure you recorded your answers. You can, of course, go back and watch this over and over and over if you would like to. Okay. Thanks for watching. Why am I wearing this? I'm wearing this because I'm sloppy. I'm a sloppy eater. I'm sloppy with this. I don't want to get the chemicals on me. That's why.